Okay, good afternoon, dear students. In last class, we discussed about the heterocyclic compounds. Then it is completed in last class. In today's class, I am going to discuss about the spectroscopic analysis. The spectroscopic analysis. This is the spectroscopy is very important tool used in chemistry. Here, until the 1945. The structure of a newly discovered organic compound was almost entirely on its formula, that is a molecular formula and a chemical reactions. The compound is converted into a known compounds. The unknown compound is converted into a known compounds by a series of specific reactions. On its was synthesis from the smaller known compounds by a specific reaction. This way to finding the structure of organic compound was time consuming. It is and not analyze here. It is not always 100% accurate, and the conclusion, whereas the understanding of the reactions here, it is carried out in a spectroscopic method. The organic chemistry has been revolutionized in past 50 years by use of spectroscopic method. In use of spectroscopic method for the determination, or it is an analysis and structure of structure determination. These methods have this spectroscopic method. We use a spectroscopic method by determining the molecular formula. It is a determination, structure determination and analysis of molecular formula. Here we use it for this spectroscopic analysis, and here have some advantages of spectroscopic analysis. In this spectroscopy, you will some advantages are there here. These advantages are very important for 5 marks in our examination. Here, the advantages of spectroscopy, spectroscopic method of analysis, and the structural determination of organic compounds or a chemical analysis of organic compounds. Here, chemical analysis and this spectroscopic analysis. It is comparison with the chemical analysis and this spectroscopic method. It comes formula and the structure determination. Here the you write here the advantages of spectroscope. Advantages of spectroscope. Advantages of spectroscopic method of analysis and structural determination of organic compounds or chemical analysis of organic compound. Here first advantage is spectroscopic method of analysis is easier and faster. The spectroscopic method of analysis, first one, these advantages are very important. Advantages of spectroscopic analysis. This is very important for 5 marks question. This is a 5 marks question. Here the spectroscopic method of analysis. First advantage, the spectroscopic method of analysis. The spectroscopic method of analysis is easier and faster. Easier and faster. This is the first advantages for spectroscopic analysis. Second one, this is the first one, and second one here, the spectral analysis is larger information will be obtained. In spectral analysis, the more and more information will be obtained, whereas in chemical analysis, many number of reactions should be carried out, get little information, many reactions, but the little information given in spectroscope, in chemical reaction, chemical analysis, in spectroscopic analysis, it's give more and more information to the unknown compounds. It is converting. In spectroscopic method means it is converting. The spectroscopy means, you know, here spectroscopy is the spectroscopy is the interaction, the definition, here the interaction between electromagnetic waves and matter. And what is here? Spectroscopy is a interaction between electromagnetic waves and matter. You know, this is what is spectroscopy, and here another advantages. The second advantage, in spectral analysis, larger information will be obtained. Second advantage, in spectral analysis, larger information, in spectral analysis, larger information will be obtained. In chemical analysis, whereas in chemical analysis, many number of reactions should be carried out. Reaction should be carried. Many number of reactions should be carried to get little information. First one is the spectroscopic method of analysis is easier and faster, and second one is the spectral analysis gives large information large information will be obtained, whereas in chemical analysis many number of reactions should be carried to get a little information. Next, third advantage, in spectral analysis, chemicals will not be wasted. Here will not waste. Here the chemical analysis will waste the chemicals. Here in spectroscopic method, the chemicals will not be wasted, whereas in chemical analysis, lots of chemicals used to do the series of chemical reactions. Here many chemicals are used in a series of chemical reactions. Here little chemicals are used for in spectroscopic method. Here it is not be wasted here by using this spectroscopic method. The third advantage in spectral analysis, In spectral analysis, third one is in spectral analysis, chemicals will not be wasted. Chemicals will not be wasted. Chemicals will not be wasted. Whereas in chemical analysis, whereas in chemical analysis, lots of chemicals used, lots of chemicals used to do the series of chemical reaction, to do the series of chemical reaction. Chemical reactions. This is the third advantage of spectroscopic analysis as compared to the chemical analysis. Next, fourth advantage, in spectral analysis, gives accurate result, and chemical analysis are not the precisely. Fourth one, in spectral analysis, gives accurate result, gives accurate result. In chemical analysis, and in chemical analysis, and in chemical analysis, and in chemical analysis are not that precise. Here, the fourth advantage of spectral analysis, the spectral analysis gives accurate result, and in chemical analysis are not that precise. It is the opposite of this. Is gives the precision, is a nearly of this accurate here. And next, fifth advantage, take a screenshot of these advantages. Next, fifth one, in spectral analysis, compound come bands. Here you are doing the spectroscopic method. You are in series of chemical reactions. Here in spectral analysis, compounds comes back. That is, a spectral analysis is a non-destructive. Here spectral analysis is a non-destructive, whereas in chemical analysis, once chemical used, we cannot get it back. We can not get it back. That is, the chemical analysis is a destructive. Here the spectroscopic method is a non-destructive. The chemical analysis method is a destructive method. This is the fifth advantage of spectroscopic analysis. Next, fifth advantage of spectral analysis. Here, in spectral analysis, compounds comes back. Fifth advantage in spectral analysis. In spectral analysis, compound comes back. That is spectral analysis is a non-destructive. That is spectral analysis is a non-destructive. Spectral analysis is a non-destructive, whereas in chemical analysis, whereas in chemical analysis, once chemical used, once chemical used, you cannot get it back. Cannot get it back. Because this is a destructive method. This is a destructive here. That is, the chemical analysis is destructive. Chemical analysis is destructive. This is the fifth advantage of spectroscopic analysis. In spectral analysis, compounds comes back. That is, spectral analysis is a non-destructive. Whereas in chemical analysis, once chemical used, you cannot get it back. That is, chemical analysis is destructive method. Next, sixth advantage. Sixth advantage in spectral analysis is the external analysis. In chemical analysis, errors will be minimum. Here, in spectral analysis, external analysis. Sixth one, in spectral analysis. Spectral analysis is external analysis. Spectral analysis is a external analysis. And chemical analysis. And chemical analysis. And chemical analysis, error will be as compared to this spectral analysis. This is the sixth advantage of spectroscopic analysis. This spectral analysis is external, it is a personal error. Here, the spectral analysis personal, that is the external here, the personal here. This is a personal, and the mental errors will be minimum. Here the method is here, the errors will be minimal in chemical analysis. These six advantages are very important for 5 marks. 5 marks question in our examination. Okay, these are the advantages. Next, study the principles of spectroscopic analysis. The principle of principles of spectral analysis. Principles of spectral analysis. Here, some principles are involved here in a spectroscopic or in a spectral analysis. First one, the 5 principles are involved in this spectral analysis. The first one, all organic molecules absorb a particular energy. You know, electromagnetic waves, electromagnetic radiations. Here, all organic molecules, any organic molecule, all the organic molecules is absorb a particular energy when they come in contact with electromagnetic radiation. You know already what is meant by electromagnetic radiation. Electromagnetic, you pass electromagnetic, some energy is absorbed. All organic molecules, some energy, the particular energy is absorbed the in a particular organic molecule by contact with electromagnetic radiation. This is the first principle of spectral analysis. First one, all organic molecules. First one, all organic molecules absorbs particular energy when they come in contact with electromagnetic radiation. This is the first principle in a spectral analysis. The all organic molecule absorbs particular energy. Here, this is a electromagnetic radiation. These are electromagnetic radiation, and any organic molecule. This organic molecule, take an organic molecule. This organic molecule is come in contact with electromagnetic radiation. This particular organic molecule, this absorb a particular energy from a electromagnetic radiation. This is the first principle. Next, second principle, second point. When molecule absorbs energy undergoes transformation which may be temporary or permanent. Here, when molecule absorbs energy undergoes transformation which may be temporary. It is a transformation takes place from one higher level or lower level of energy levels. It is a transformation takes place. Here, it may be permanent or it is a temporary. This is a second principle. When molecule absorbs. Second one. When molecule absorbs energy undergoes transformation which may be temporary or permanent. Which may be temporary or permanent. This is the second principle. Next, third one. Here, the lower energy radiation causes molecular rotation or bond vibration. Here, You have a lower energy. When particular energy is low, it is a lower energy, and lower energy causes the lower energy radiation causes molecular rotation or bond vibration, whereas higher energy radiation causes or results in promotion of electrons from lower energy to higher energy level, or band or bond breakage can occur here. This is a third principle. Here the third principle, lower energy radiation lower energy radiation causes molecular rotation, causes molecular rotation or bond vibration. Molecular rotation or bond vibration. Molecular rotation or bond vibration. Whereas higher energy radiation, whereas higher energy radiation, higher energy radiation causes or results or results in promotion of electrons from lower energy level to higher energy level. From lower energy level to higher energy level. Higher energy level or bond breakage can occur, or bond breakage can occur. This is a third principle. Here, lower energy radiation causes molecular rotation or bond vibration, whereas higher energy radiation causes or results in the transformation of electrons from lower energy level to higher energy level, or bond breakage occurs here. This is a third principle. Next, fourth principle. The fourth principle is a particular molecule. When particular molecule absorbs a particular wavelength of radiation, and a particular organic molecule, it absorbs a particular wavelength of radiation for a particular transition depending upon its molecular structure. Depending upon the molecular structure. This is a fourth principle. Fourth one, particular molecule absorbs a particular radiation. Particular molecule absorbs particular wavelength of radiation or wavelength of radiation. Particular wavelength of radiation. Particular wavelength of radiation for particular transition for particular transition depending upon its molecular structure. Depending upon its molecular structure. This is the fourth principle. Next, fifth principle. Fifth one here. The fourth one is a particular molecule absorbs a particular wavelength. Here you know particular wavelength. This is the electromagnetic radiation. This is the energy, and here the waves of formation. This difference is a wavelength. This difference is known as a wavelength here. Here you know the particular molecule absorbs particular wavelength of radiation for particular transition depending upon its molecular structure. This is a fourth principle. Next, fifth one. By knowing the spectral values or a spectrum of known compounds, by correlating these values with the spectral details of unknown compound, we can analyze and can determine the structural features of the unknown compounds. Here the fifth spectral analysis principle. By knowing spectral values are correlating these values, spectral values, or it is a spectrum of known compound, spectrum of known compounds, by correlating these values correlating these values with the spectral details of with the spectral details of unknown compound we can analyze and can determine the and can analyze and can determine the structural features of the unknown compound. Structural features of the unknown compound. We'll see here how to determine the structural formula or analysis in spectroscopic analysis, the principle by knowing the spectral values or a spectrum of known compounds by correlating these known compounds and unknown compounds, the correlating of these values with the spectral details of unknown compound. You can hear the spectral details, you can see the spectral details, you find out the unknown compound. Here you can analyze and determine the structural features of the unknown compound. I believe. Know the which compound is present or the name of the compound you have to find out from this spectroscopic principle. Use these principles for finding the unknown compound here, or you give the details of the features of the compound. These are the principles. These 5 principles are also very important in spectroscopic method. Okay, I stop here only. I continue in tomorrow class.